Hey, this is Mr. C, and thanks for tuning into your latest math lesson. This is the second lesson of Chapter 5, Prime Factorization. Once you're done writing your name and your date and the title, we're moving on in 3, 2, 1. At this time, please check your answers to your homework. Moving on in 3, 2, 1. So let's zoom in and learn more about prime factorization. So how can you write the prime factorization of a number? Whole numbers greater than 1 are either prime or composite numbers. Or let's find out what prime means. A prime number has exactly two factors, 1 and itself. The numbers 2, 3, and 5 are prime numbers, and those are not the only prime numbers. Those are just the smallest prime numbers. So I'm looking right over here. I see that 2 is a prime number. Only 1 times 2 that's the only way you can get 2. 3 is also a prime number. 1 times 3 is the only way you can get 3. And let's look down here. 5 is the same way. There's nothing you can divide 5 by except for 1 and 5. So let's move on. So now we're going to talk about a composite number. A composite number has more than two factors and can be written as the product of its prime factors. I see the word product. I know that I'm going to see a multiplication sign because I know that product means the answer to a multiplication problem. And when you write it like this, it will actually end up looking down like this, but we're going to get to that in just a second. Then that's called the prime factorization. So for example, 4 is a composite number. The factors of 4 are 1, 2, and 4. 2 is its only prime factor. The prime factorization of 4 is 2 times 2, or, for those of you who remember exponents, 2 squared, or 2 to the second power, which means the same exact thing as 2 times 2. If this is composite, I see 3 factors instead of just 1 and itself. It's 1, 2, and 4. A prime number would have just been 1 and 4, so this is composite because there are other factors that it has. So let's zoom in and talk about the prime factorization of 60. So first, I'm kind of drawing on my background knowledge of the divisibility rules from 5-1, and I know that it's even. This is not the only way you could do this, but I do know that it's divisible by 2 because it's even. And so I'm asking myself, 2 times something is 60, 2 times 30. And I'm thinking, is this prime? No, I can break this number down even more. And as we follow it down, 30 is now made into 2 times 15. And I'm looking at 15 and I'm thinking, is that a prime number? Can I break that down? Well, we're going to carry the 2's down, and then we know that 15 is 3 times 5. And I'm thinking, can I break this down anymore? No. And I'm asking myself, how did they get 2 squared? Oh, they combined the similar numbers, and then they put the exponent to represent how many times they had that number. They had that number twice. So here is our prime factorization for the experts. Let's move on. With the clue word of fire hydrant. Here are your vocab notes. I circled them to represent what definition goes with what picture, so therefore this definition goes with this picture. And I should have given you a printout of that so you can paste that in your notes right now after you cut it. We're moving on in 3, 2, 1. So here's example 1, and let's zoom in. We're going to talk about 2 ways that you could do prime factorization. So let's do one way. So to find the prime factorization of 72, let's begin with the smallest prime factor and write the factors until all the factors are prime numbers. So 72, one of the things that I know I can divide it by, again, this is not the only way you can make this tree, but you can divide it by 2 because I'm looking at this last digit and I see it's even. So I know it's 2, and then I would have divided 72 and gotten 36, just like right here. And then I'm looking at 36 and I see that that can be divided as well. I see the last number is even, and so we brought down another 2. And so I know that 36 is 2 times 18. Notice how we're just bringing whatever we have, we just continue to bring it down in a tree-like fashion, an upside-down pyramid. So we have 2 times 18. And now I'm thinking, oh, 18, that's not a prime number. I can divide that by something other than 1 and itself. Well, I also know that 18 can be divided by 2. Notice how they're continuing to bring down the numbers. 2 times 9 is 18. I'm thinking, can 9 be divided by anything? Well, 3 times 3 is 9. And then what I've ended up with is all prime factors. These are all prime. Only 1 and itself are the factors of these things. All right, so we take these numbers that we got at the bottom of our factor tree, and I see that we rewrote them as 72 equals, if you multiply all these numbers by each other, you will get 72. And so now we're looking at, you might ask yourself, why are these red? Well, they're the same number, and so now we put them as an exponent. And I'm asking myself, how many 3's are there? There's 2, and so that's what we put as the exponent there. So 2 cubed, or 2 to the 3rd power, times 2 squared, or 2 to the 2nd power, equals 72. And as I see down here, there's only one prime factorization for any number. So no matter how I break this tree up, let's say I did 2 times 36, and then down here, instead of 2 times 18, I did 6 times 6. At the end, I would still get this same answer, and I would still get this same prime factorization. You'll always get that same answer. So let's go on and look at a different way you could do this. So I see on this side that we just did, I see that we tried to do a prime number times another number. 36 is a prime number times another number. 18 is a prime number 2 times another number. And we tried to only do prime numbers. But the other way that we could do it, and let's zoom in on this, is that we could begin with any factors, any 2 factors of 72, and then write factors until all the factors are prime numbers. So we're still going to get the same answer, but as I was talking about before, oh, maybe you know that 6 times 12 is 72. So we have 6 times 12. Notice how they're not prime, and so we're going to continue to break them down. I'm looking at 6, and I know that 2 times 3 is 6. And I look at 12, and one of the ways to get 12, but not the only way, is 3 times 4. And I'm looking at these, and I notice that I bring the 3 down because it's prime. I'm bringing the 3 down, and the 2 is already prime, so I'm bringing that down. And we continue to break down this 4. 2 times 2 is 4. What we end up with, again, is the same exact prime numbers as last time, and let's just make sure that's true. Let's look at this. Notice how we have the numbers at the bottom, and then over here, we put them in order from smallest to biggest. So I have a 2, and I put it right here. I have a 2, I put it right here. I have a 2, I put it right here, 3, 3, 3, 3. And they did the same thing over here, except it just happened to be in the right order already. But you get exactly the same answer no matter how you break it down. If you're wondering what you need to write, I want you to pick one of these factor trees and also the accompanying prime factorization to the right of it and copy that down. Pick either the red or the blue. And we're moving on in 3, 2, 1. So here's example 2. For these 3 numbers, 1, 2, and 7, write the prime factorization of them. If they're prime, just write prime. If you're ready for the answers, I'm showing them in 3, 2, 1. All right, and here are your answers, and what you specifically should look at is if you got the same prime factorization as me. And the factor trees might look a little different, but you should have had the same prime factorization. Moving on in 3, 2, 1. So here's independent or partners practice. And when you'd like to come back for the answers, come back in 3, 2, 1. Here is what you should have gotten for the prime factorization for each of these. This actually says 5 like that. This is 2 times 5 times 7. Make those easier to see. All right, and when you're ready for the group math game answers, I'm going to show you those in 3, 2, 1. Here are your answers to the group math game. Thank you for watching the video. I hope you learned a lot, and never forget, you are awesome.